Let's go ahead and find S sub n and S for the following telescoping series. The first thing we're going to need to do is rewrite this expression in the traditional telescoping way so that we can find S sub n. So we are going to factor this denominator, and we are going to use the PFD method to write it as a sum of two partial fractions. The next step is to multiply both sides by the denominator on the left, which is going to create this PFD equation. And because both of the zeros are coming from linear factors, we can use the convenient value method. That will be quite quick here. So I'll choose k equals -1, and then I'll plug that -1 in for all the k's in the equation above. Plugging in here for this k, we're going to have 2a. Plugging in -1 over here gives 0. So this is going to tell us that a is 1. Plugging in the convenient value of -3. On the left there is no k, so we keep a 2 on the left. -3 here gives 0. -3 here gives -2 times b. So this tells us that b is -1. So this allows us to rewrite the series from 0 to infinity as 1 divided by k plus 1 minus 1 over k plus 3. This form is going to allow us to find S sub n. We need to find S sub n so that we can then take the limit of S sub n in order to get the sum of the series. So S sub n is the sum of the first n terms of the series. So we have to be careful here because this series starts with an index value of 0. So that means that the first n terms will look like this. The first term is found by plugging in the first index value of 0. So we're going to get 1 over 1 minus 1 over 3. So this is the first term. So I'm going to, down below, I'm going to just write the term number. This is term number 1. And that's different from the index value, though. So above, I'm going to put the k value, the index value. This was when k was 0. Okay. Now, the second term will be found by plugging in the second index value, which is 1. So we'll get 1/2 minus 1 over 4. So this index value is 1, but the term number is 2. Let's do one more in this pattern here. So now we're going to plug in a index value of 2 to get the third term. So we're plugging in a 2, we're getting 1/3 minus 1/5. And this is going to carry on. Now we need a couple of terms towards the end of this partial sum to be able to establish the pattern. So we want the sum of the first n terms. So the nth term is going to be the last term in this partial sum, and the n minus first term will come right before it. So we need to know what the corresponding index values are. So we can see a pattern here. The term number and the index value differ by 1. So we repeatedly subtract 1 from the green to get the red. To get the second term, we subtract 1, and we're going to be plugging in a k value of 1. So the k value is always 1 less than the term number. So we subtract 1 from each of these. So now we can come on through and find the n minus first term. The n minus first term is going to be found by plugging in n minus 2. So the n minus first term, we plug in n minus 2, and we're going to get 1 over n minus 1 minus 1 over n plus 1. And then the nth term is going to be found by plugging in n minus 1. We plug in n minus 1, and we'll end up with 1 over n and minus 1 over n plus 2. So there is our expression for the nth partial sum. And now we can notice the cancellation pattern. So the cancellation pattern, as we're moving from left to right, we notice the second part of that term is going to cancel with the first part of the term, the first part of the term that we find after skipping a term. Let's look at the next term. So this term, this 1/2 is, that 1/2 is not canceling with anything. This one, -1/4, this is going to cancel with the first part of the term after a skip. So that's going to cancel with something in here. So as we're moving left to right, it's all of these second parts that will cancel with something to the right after we skip a term. And now we want to do the reverse coming backwards. So if we're coming backwards, if we start, let's just think about being right here. If we're going from right to left, we're thinking about canceling the first part with something to the left after a skip. So if we're going right to left, it's these first parts that are going to cancel with something to the left after a skip. And what this tells us is that the remaining parts that did not cancel will have a 1 and a 1/2 from the first two terms. And from the last two terms, we're going to have the -1/n+1 and the -1/n+2. So this is the expression for S sub n. So the sum of the first n terms. Now to find S, the sum of the series, we will take the limit of S sub n as n goes to infinity. And what we notice is that these two terms here are both going to go to 0 as n goes to infinity, giving us a sum of 1 plus 1/2, which is 3/2. That will be the sum of this telescoping series.